Hello everybody, my name is Ed Maselli. I'm a member of the OxiKit and Pillar Tribe, and we are building an oxygen concentrator. Today I'm going to show you how it works, what the parts do, and try to explain some of the theory. So let me show you what's going on here. This is our concentrator. This is the one that works really well. So we have a compressor. This compressor is about a 2 horsepower compressor. This is how much we actually needed to get 15 liters per minute output. It is quite a bit of hefty compressor. The air comes the pressurized air. We're running around 30 psi at the moment with this compressor, so that the air comes out of the compressor and it goes into the cooling coils. This is a very simple, effective way of cooling the air. I believe it's about 25 foot of copper coil, so you can actually feel the difference of the hot air on the top and as it cools at the bottom. So the air comes directly from the compressor into the cooling coils. After the cooling coils, it actually goes into the input pressure regulator. This is set at around 30 psi maximum. So after the input pressure regulator, it is split and it goes into these two valves. Those two valves are 3-port 2-way valves. So the input comes from one side, and this is the purge exhaust. So this valve is going to switch from either getting pressurized air or from emptying the sieve through this opening. We have two sieves, each one filled with about 3 pounds of zeolite. We're using 3-inch pipe, and I have other videos showing the details of the inside of each sieve canister, the details of the screens that are holding the zeolite in, the springs that are keeping it compressed, and so forth. So air comes in from the bottom, it goes through the zeolite absorbs the nitrogen, and then concentrated oxygen goes out from the top. When it goes out from the top, as you can see, it goes into this T's, and it splits off. It splits off into as you can see here. So we have this Y configuration with orifices inside. Each of these orifices has a 1.6 millimeter diameter hole in it. I made those using aluminum rod drilled in the center with a 1.6 millimeter drill bit, and then I cleaned them up a little bit. What this effectively does is it splits off. The concentrated oxygen comes out of the active sieve, and it's split. Half of it goes into the surge tank. This is our surge tank, and half of it goes into the sieve that's being purged at the moment. And so what this does is the oxygen pushes out the remaining nitrogen in that sieve, because now it's under low pressure, and it pushes out the nitrogen, and it fills the empty sieve with oxygen. During the next cycle, whenever this sieve starts to pressurize, it now has some concentrated oxygen in there, and it actually gets enriched even more. So that increases our concentration, and then it feeds again. As it comes out, it's split. Half of it goes into the surge tank to be consumed. The other half goes into the empty sieve to fill it, to push out the nitrogen, and to enrich it even higher than it was when it came out of the first sieve. This is our equalization valve. What this does is, after the sieve is purged, this opens up a little bit to allow the full sieve canister to start to pressurize the empty canister. This way we're utilizing that pressurized oxygen to fill the canister to ramp up the pressure quicker. This helps with the nitrogen absorption, because the higher the pressure, the more nitrogen is absorbed. The output goes into a surge tank. The surge tank is basically an empty canister that is supposed to temporarily hold the oxygen before it's consumed. The output of the surge tank goes into the second pressure regulator. This is a low pressure regulator set at around 7 or 8 psi. The output from this pressure regulator then goes into our output flow meter. This output flow meter is set to 15 LPM, and then the output from the flow meter comes out. It's split here. One side goes into our mask. The other side is going into our sensor, our oxygen meter. This is what's going to tell us if it's actually making oxygen or not. This flow meter is set to about 300 milliliters per minute, because the flow meter doesn't require very much flow in order to measure it, and it's actually, as you can see the label, it's 300 milliliters maximum. Okay, so now I'm going to go ahead and turn it on. The electronics, let me talk about the electronics. We're using an Arduino board to control the timing. So the Arduino board is very simple, very easy to use, very cheap, and it's very easy to get. The Arduino board controls a relay board. This is an eight relay board. We're only using 3 of them actually, or 4 of them, I believe. One of them is used for turning on the compressor, but it's not used right now. So basically we're only using 3 of them because we have 3 valves: equalization valve and 2 input valves. So we are going to make the code available. We're using about a 5-second cycle for each active sieve, and a 300 millisecond equalization cycle, along with a 300 millisecond fill cycle. I'm gonna go and turn on the compressor, and this will get it going. We're also using a cooling fan next to the compressor. This fan keeps it cool because after several hours of running, it starts to heat up a little bit. Okay, it's breathing, as you can see. The pressures are ramping up. You can see from the pressure gauges how each sieve pressurizes and then it empties, and then the next one pressurizes and it empties. Our storage tank is holding here, about 10 psi, I believe. 15. And this is our and then from the back, you can see how the valves are switching and then they're encouraging. So the output of the flow meter is currently putting out 15 LPM. And then the split, all through, we go into our, let me go adjust this down here. Okay. Currently we're making 96.9% oxygen. This is hot, and this is pretty cool. I mean, it's comfortable to touch.